Hello, this is Jie Zhao, and this video is the second part of my final presentation video for my system engineering class. And if you are interested in the first part, please watch my last video. Now, let's get started. In order to ensure the reliability and safety of the electric vehicle system, we need to test every component. So, we test the battery first. Engineers model the battery as 16 lithium-ion cells and then use the dynamic stress test cycle to analyze the charge and discharge performance of Li-ion battery. First, fully charge the battery and left the battery at open circuit state for 4 hours and test it according to the DST cycle condition. The experimental data is shown in the table. Compared with other batteries, Li-ion batteries have high energy density and high capacity. And then engineers test the working temperature of Li-ion battery. As shown in the figure, when the operating temperature decreases, the battery capacity decreases significantly. At minus 30 degrees Celsius, the battery's capacity is reduced by 20%. This is because when the temperature drops, the active material in the battery is not fully utilized. Therefore, the operating temperature of Li-ion battery should be kept between minus 20 degrees to 50 degrees Celsius. Now let's test the motor. The first DC motor was invented by British scientists in 1832, and since then, DC motors have been widely used in electric vehicle system. For typical medium-sized electric vehicles, the propulsion power is between 3 to 7 kilowatts, and the battery voltage should be in the range of 50 to 100 volts. The experiment result shows that the battery voltage of a series DC motor is 72 volts, and the propulsion power is 6 kilowatts, which means series DC motor can provide enough power for electric vehicles. Well, now let's talk about the wireless charging technology. The IPT was first applied to the industrial field in 1995. Later, due to the convenience and efficiency of this technology, it was gradually shifted to designs that can charge the battery of electric vehicle under both stationary and dynamic conditions. And for now, the most advanced IPT technology can transmit 5 kilowatts of power, and the transmission efficiency is around 80% to 95%. Also, the charging distance have also been improved to 25 centimeters. Well, both CASE and ORNL system are IPT charging system. As shown in the table, they are both suitable for charging electric vehicles. The next part is engineering design. I believe that for most electric vehicle users, in addition to the performance of electric vehicle, their most concerned thing should be the safety and reliability of electric vehicles. So we need to conduct a reliability assessment. Among all the evaluation models, the Markov model is the most powerful and effective. Therefore, we use Markov model to test the probability of electric vehicles. The Markov model can be expressed as a probability matrix. The elements of the matrix are the probabilities of transition from one state to another. So, the stable probability of the system can be calculated as the sum of all state probability. The system state transition diagram is as shown, and as we can see, the Markov model introduces two parameters, lambda and mu, which are the failure probability and the repair probability, which means the system can be repaired in a failed state. Now we can get the expressions of mean maintenance time, availability, and unavailability of the system. If we assumed that the electric motor and the battery in the electric vehicle system are repairable components, then we can draw the Markov state diagram of the system, in which lambda1, mu1, lambda2, and mu2 represent the failure rate and the mean repair rate of motor and battery respectively. According to the state diagram, the transition probability matrix P can be written as. Then the reliability probability and failure probability can be written as. Among which P1 is the system reliability probability and P2, P3, and P4 are the system failure probability. But the electric vehicle is a series system. In other words, the battery supplies power to the motor through converters, which means if one component fails, the other components cannot work. Therefore, the electric vehicle system doesn't have 4 modes but only has 2. Mode 1 is the state that all components are intact, and Mode 2 is the state that at least one component is broken. Now we assume the electric vehicle system has only 2 components, the motor and the battery. Then the simplified Markov model parameters can be expressed as the other components of the electric vehicle can be connected in series like the battery and the motor, so all the component states can be simplified according to the above method. This table shows the simplified failure rate and mean maintenance time rate of electric vehicle system. Using the above data and the formulas of reliability and unreliability, the stability of pure electric vehicles can be obtained, as shown in the table below. According to the data in table, we can come to a conclusion that pure electric vehicles are safer than gasoline-powered vehicles. Although we have individually tested the stability of each component, the system still may have defects when all the components are integrated. Therefore, we need to evaluate the whole system considering the input, output, and the ambient environment. This figure shows the operation of an electric vehicle. It can be seen that extreme weather conditions can cause electric vehicles to malfunction during driving. So it is necessary to simulate the driving process under an extreme condition, like the cold weather. Engineers use 2 different types of pure electric vehicles to test. One is a Leaf 2012 with Li-ion battery produced by Nissan. The other one is an iMOV with Li-ion battery from Mitsubishi. Both these 2 models were tested in actual driving in Canada. The experiment is only conducted on the selected date to ensure the ambient temperature range is 25 degrees Celsius to minus 25 degrees Celsius. The driving route of the 2 vehicles is shown in the figure. The endpoint of the route is a campus with charging equipment. Both vehicles are fully charged before departure, and each vehicle was driven until the dashboard shows the battery is depleted. During the test, the driver manually records the odometer reading every hour. So, at last, a total of 21 experiments were completed. Experimental data is as shown in the figure. As we can see, the longest travel distance of a Nissan Leaf 2012 is 165 kilometers and is about 120 kilometers for Mitsubishi iMOV. During winter months, the minimum travel distance for Leaf 2012 is 48 kilometers and is about 43 kilometers for iMOV. So we can have a conclusion. Compared with normal weather conditions, the travel distance drops to 30% to 35% under cold condition. And the additional impact caused by excessive use of air conditioning in extreme weather will exacerbate the power consumption speed, thereby further reducing the driving range of electric vehicles. Moreover, studies have shown that the charging speed of the battery will also decrease in extreme environments. Engineers believe that adding a heating subsystem to the battery system can solve the problem of low capacity and low charging speed in cold conditions, and the flowchart of a heating subsystem is shown in the figure. Okay, the last stage is the post-development stage. So far, we have discussed the motor, battery, and charging equipment of the electric vehicle system. A complete electric vehicle product also needs a body frame and auxiliary system. So, in order to improve the battery efficiency, the mass of the car must be reduced, and the air resistance and rolling resistance have to be minimized. As we all know, the more aerodynamics a vehicle is, the lower is its resistance and higher is its fuel efficiency. Therefore, the body design of electric vehicles needs to be as aerodynamic as possible, such as reducing the drag caused by the antennas, wipers, and wing mirrors on the body as much as possible. The antenna doesn't need to be installed outside the vehicle body, and the wing mirror can also be replaced by an electronic video system, which can be installed inside the vehicle. In addition to being aerodynamic, the body also needs to meet the following conditions. Well, first things first, it has to be rigid and impact resistant and also lightweight. So the choice of the body material is very important. The body frame material needs to be hard enough and also has certain ductility. Well, among all the metal materials, steel is relatively hard and is also the body and chassis material of traditional gasoline-powered vehicles, but it is not suitable for electric vehicles because of its low weight density, which results in a relatively high weight. However, composite materials are relatively more suitable for electric vehicles. As can be seen from the table, carbon fiber has the best rigidity to mass, almost 6 times of other materials. Therefore, carbon fiber material is the best choice for constructing the body of electric vehicles. Compared with gasoline-powered vehicles, the chassis design of electric vehicles is more flexible because the batteries and motors of electric vehicles can be placed anywhere on the chassis according to design requirements. They do not need to be put together and can change shape and size according to design needs. For example, the HY-Wire model, the pure electricity vehicle from General Motors, uses a new chassis design as shown in the figure. The chassis contains multiple batteries, battery heating system, steering system, and a radiator. The subtlety of this chassis is that motors are installed in the wheels, which saves a lot of space. About the auxiliary systems of electric vehicles, such as traction control system, ABS system, and acceleration stability maintenance system, and etc., can learn from traditional gasoline-powered vehicles. The next part is operation and support. The control system of the electric vehicle is the most important part of the auxiliary system. It involves the management of the battery, the power distribution of the engine, and the overall safety of the vehicle. Therefore, the data of the control system is an important indicator to measure the safety and reliability of electric vehicles. Well, wireless communication technology is widely used in electric data transmission, but the transmission speed is slow and unstable and is no longer applicable to modern vehicles. GPRS is proposed to achieve a wide range and fast-speed data transmission. Well, the working principle of the GPRS platform is shown in the figure. The onboard equipment are installed inside the car, and the operation data and GPS data are collected by CAN bus, and finally all data is transmitted to GPRS network. The damage of some non-essential components such as wipers or turn signals will not affect the driving of the vehicle, but if the batteries are damaged, then the vehicle will most likely break down. So engineers have proposed 2 methods to remedy the problem of battery being suddenly damaged during driving. Since the battery of the electric car can be disassembled, if the car owner has long-distance plans such as driving to travel, he can carry a set of batteries with the car to prevent battery damage. In addition, engineers recommend that all charging stations in cities should be equipped with sufficient batteries. If the batteries are damaged during commuting to work, they can be replaced at a nearby charging station. Okay, finally, let's summarize. The electric vehicle system selected the pure electric vehicles to achieve the goal of zero emissions. Taking into account the driving range of electric vehicles, a lightweight, large-capacity Li-ion battery was selected as the power source. In order to allow electric vehicles to have similar driving speeds as gasoline-powered vehicles, a series DC motor was selected as the motor. Well, the chassis and the frame of the electric car are made of carbon fiber material, which is lightweight and also rigid, and the components such as mirrors and antennas that will increase the drag are designed to be installed in the car. The wireless charging is safer and faster than plug-in charging, so the system selected wireless IPT charging to charge electric vehicles. And also, the vehicle-to-grid system can make electricity flow between electric vehicles and the urban power grid. It can make full use of energy while reducing the cost of electric vehicles. The system engineering lesson let me realize how a product was developed from the concept development stage to engineering development stage, finally to the post-development stage. Each stage is to perfect the product design, from the requirements to the maintenance and finally the repair. Every stage is essential. So thank you for watching my video. I hope you enjoy it, and everybody please stay safe and healthy. I will see you next time.